Okay, so we're going to go ahead and do lesson 4.4, part 1. This is a fairly long lesson, so we'll just do a brief portion right now just to get you started. We'll probably do about the first 5 slides or so of this PowerPoint. So anyhow, let's take a look. So we're going to start talking about logarithms and the graphs of logarithms in this lesson. And like I said, there's a lot to this. You might recall that when we were working on exponential functions, that there were about 6 properties of exponents. And what we're going to find out is that logarithms have about 6 properties also. And so it's going to take some work. And this is a brand new function, so this will take some getting used to. And so let's just take a look at it. So you have these already on your study guide that I've given you that goes along with this PowerPoint. Students will be able to evaluate logarithms and to graph logarithms. Okay, so what is the relationship between exponential functions and logarithm functions? So we're going to look at that. But before we do that, let's just review a little bit. This is a warm-up problem, and I'm going to set up the problem for you, and then I will let you finish it on your own. You might recall, let me get my pen going here. Right there. You might recall that when we were dealing with exponential functions that they might be a growth, or there might be an exponential decay, or there might be a compounded interest type problem. And last time we were talking about compounded interest, we were looking for the word continuously. And if there was a continuous compounded interest, then we use this formula right here. The future value is equal to the principal. And anytime you have a continuous type situation, the application calls for the natural base, which is base e raised to the r times t. So basically all you need to do is plug these numbers in, and we'll find out what happens. Like for example, we start off with a $10,000 deposit. That's the principal. That number goes in there. And then the rate is this percentage right here, but rates we usually write as a decimal, so we're going to write the rate as 0.03, and then that will go in right here. And then how much time are we doing this for? If we go from June 1st, 2008 until June 1st, 2010, that looks like time is 2. So the time is for 2 years. And so that goes in here. And so basically you plug those numbers in. Now keep in mind when you do this in a calculator, you might want to multiply those two together first. So then when you put an E in your calculator, you can use that caret key, and then you're going to put like 0.06, and that's multiplied those two together. And so here you're going to have like 10,000. Okay, and then you multiply that by E. Use the caret key. Sometimes when you use our calculators, it will automatically put you up in the exponent. You won't need the caret key. Okay, so I'll let you do that problem. That's a little review of what we've been doing. And now let's get back to the PowerPoint. Find the inverse. Well, as you might recall from the previous chapter, like in chapter 3, we found out we can find an inverse by switching the variables. So in this case, I'm not going to do it all for you, but you start out by switching the variables. So you're going to have x is equal to 3 times y minus 5. And then the idea is to solve this equation for y. And you have y is equal to whatever right here. Now when we're doing inverses, the thing to realize is that this isn't really y when we're done, because y is equal to this. We just do this switch variable trick to find the inverse. So when we're done, we need to eliminate that and rewrite it as the inverse function. And for the inverse function, we just put like a -1 right there. So that's what we do. Basically, this is our function. We start off with f of x is equal to 3x minus 5. And our job is to find the inverse function. So anyhow, I'll let you do that. Solve this equation for y, and then call it f inverse. Okay, so you're going to move the 5 over and then divide by 3. Simple as that. Okay, so why do we bring up the inverse in this section? Well, the reason why is because a logarithm is the inverse of an exponential function. So let me talk about that briefly, see if that makes sense. So when we were doing like y is equal to x squared, if this was equal to f of x, okay, f of x is equal to a function of x. The inverse we said is equal to the square root of x. And really there could be like a plus or minus right here. And so how did we do that? Well, what we do is we switch variables. So we put x here is equal to y squared. And then we solve for y. Well, to solve for y, we take a square root here and a square root here. When you're solving for a variable, though, you don't know whether you have the positive root or the negative root. So in this case, we put plus or minus here. And so when you get done here, you get y is equal to plus or minus the square root of x. Now again, just like in the previous slide, we don't call this y anymore because y was actually equal to x squared. This is actually the inverse. So we'll call this the inverse function. And again, that's what we do. We do this switch variable trick. Well, so here's the problem. When we have an exponential function, let's say we have f of x is equal to, well, we'll call it y again, equal to, let's say, it's equal to 2 to the x. So we're looking at this function right here, and we're trying to find the inverse. Well, so what happens is we switch variables, and so we have x is here, and we have 2 to the y. Well, now how do we solve this equation for y? Well, it was kind of easy when we had powers, but now this is the base here is x, and it's easy. We can take the square root because we know what the power is. But now notice the variable is the exponent, and we don't really know how to solve this equation. You could say, well, I know what I'll do. I'll do this. I'll just do a simple trick. I'm going to raise this to the 1 over y power. I'll raise this side over 1 over y power. Well, what happens then is that this y here cancels out with this y, but then you have x to the 1 over y is equal to 2. Well, that's nice. I got rid of the y on the right side, but now it's on the left side. And then you say, well, I know how to get rid of that. I could raise this whole thing to the y power. But I have to do the same thing on this side, so I'm going to raise it to the y power. And so we take the y here and cancel off that one, and we get x is equal to 2 to the y. Well, hey, that's exactly what we started out with right up here. So all we're doing is going around in circles. So let's look at this again. We're starting out here with x is equal to 2 to the y. How do we solve this thing and get y by itself? That is the big question. Well, it turns out that mathematicians didn't have a function that did this. There's no algebraic thing that we can do. We can't square both sides. We can't cube both sides. We can't take the square root of both sides. We can't There's nothing we can do algebraically up to this point. So what mathematicians had to do was create a logarithm. It's a brand new function, and that function is the inverse of the exponential function. So what we're going to spend our time with in the next slide or two is learning how to write things in logarithmic form. Now here's the thing to realize. A logarithm is still an exponent. It's just an exponent that is the inverse of the exponential function. So it seems a little bit confusing at first, so we're just going to walk through this a little bit slowly at first. Our first priority is just to be able to switch from exponential form to logarithmic form. So let's go back to the PowerPoint and we'll learn about logarithms a little bit here. Okay, so you know that 2 squared is equal to 4 and 2 cubed is equal to 8. However, for what value does 2 to the x equal 6? And this runs into the same problem. What we'd have to do is start using a calculator and start guessing a whole bunch of x values and find out when this is equal to 6. Well, anyhow, mathematicians define an x value using a logarithm. And take a look at this. This is really bizarre. What is that? Okay, so one of the things we need to do is realize what are all these different parts. There's a log, L-O-G. Well, that's just abbreviation for logarithm. And this number here, what is that? That turns out to be the base. Notice there's the base right here, and it's the same number right there. Okay, so that's just what we call the base. Okay. And so anyhow, the definition of logarithm can be generalized as follows. Let's take a look at this. What is this here? Alright, so here's the definition of a logarithm. Remember, it's going to be the inverse, so we should not be surprised if there's like a switch in variables. So let's see how this works. The key to writing well, here's the exponential function. Here's the exponential function. And here's its equivalent logarithmic expression. They're both equivalent, okay? But notice there's a connection between the two. And that's what I want you to notice in this first part. The base here is the same as here. Okay, those two are the same. And then notice what happens if we're going to go from logarithmic form to exponential form over here. All we need to do is switch the two here. You see, so the x moved up here and the y moved over to here. So let me show you what this means. Like for example, if we have log base 2 of y is equal to x, then to go to exponential form over here, we're going to put 2 here, and now these two switch places. Okay, so we're going to put x here is equal to y. So there you have it. This is exponential form that we were talking about just a few moments ago. Y is equal to 2 to the x. And this turns out to be the inverse function. Except for well, we'll deal with this later. But but this is the logarithmic equivalent of this exponential function. It's equal to this. Now again, if you're going from exponential form and you're going to logarithmic form, you just simply write out log and then realize, hey, this is the base. The base goes here. The base goes here. It's written kind of small, kind of like an exponent is written kind of small. And then slightly at the same level of this, we got to switch variables. So we're going to put y here is equal to x. So again, these two switch places. Well, I know that looks kind of confusing. Let's go back and let's write some exponent and logarithmic form. We'll switch back and forth doing this. So let's move to the next slide. and I'm going to show you some examples. And this is where we want to stop today. I'm going to get done with the slide here. So rewrite the equation in exponential form. Okay. So remember what we had. We had log with a certain base, and then we had like y here with x, and that's equal. We had an if and only if, so we'll put a double arrow here. That's equal to, what you do is you put the base over here, and now you switch these two. So you put x here, and you put y here. Okay, so if we want to go to exponential form, then watch what happens. We're gonna put the base over here. We're gonna put this base here, and then these two switch places. Okay. So we're gonna put the 5 here, and it's equal to 32. And that makes sense because 2 times 2 times 2 times 2 times 2 is equal to 32. Huh, kind of interesting. Okay, I know this sounds kind of dumb. You know, what the heck? I mean, it is a little bit bizarre at first, but this is the new function that we have to deal with, and it's going to turn out to be the inverse function for an exponential function. Okay, so let's move on to the second example. I'll put a few more of these up here. Okay, so what's this one mean? Well, remember the key to all of these is that you keep the base. So the base is the same. And so I'm going to write 10, and then these two switch places. So 10 to the 0 is equal to 1. And of course you know that because any number to the 0 power is equal to 1. Now this one is another one that's kind of interesting. So the base is going to be the same. Okay, so 9. And then these two switch places. Okay, so think of this as a base to an exponent, and then they switch places. So this is going to be 1. Well, what's 9 to the 1 power? That's equal to 9, right? And there you have it. So this is the logarithmic form. This is the exponential form. Okay? So now how about this one? This one's a little bit tricky. Okay? So the base is 1/5. So 1/5 is the base. And then again, these two are going to switch places. So we're going to put -2 is equal to 25. Oh, is that really true? Okay, well, let's check this out and see if it's true. Okay, so we have a negative exponent. So this is equal to 1 to the -2 over 5 to the -2. Well, now because we have a negative exponent, we move this one down to the denominator, move this one up to the numerator, and so we end up with 5 squared over 1 squared. Well, that's equal to 25 over 1, which is equal to 25. And so, yeah, that's true. So anyhow, in this first basic lesson, we're just learning to go from exponential form to logarithmic form, and eventually we'll go back and forth. And so I want to stop right here, and we'll start part 2 tomorrow. Okay.